In this video, I'll talk about how to simplify radicals and also how to rationalize the denominator when you have a fraction with a radical in the denominator. So let's start off with the example. I have the square root of 200 that I want to simplify. What I'll do is I'll break the number 200 into a perfect square times another number. So in this case, I can write 100 times 2. Now the 100 is a perfect square, so that can come out, and that's going to come out as a 10. And the 2 is not a perfect square, that has to stay in. So my final answer for this is 10 times the square root of 2. And I like to try to put the perfect square first. That way that's coming out front, and what's at on the right hand side stays under the radical. Now let's take a look at simplifying a fraction with a radical in the denominator. Here I have 2 over the square root of 29. This is a kind of fraction that you would see fairly commonly in a trigonometry class, and I need to rewrite this so that I don't have a radical in the denominator anymore, and that's called rationalizing the denominator. So what I'll do is I'll multiply both the top and bottom by the square root of 29, and when I do that, the denominator just becomes 29, and the numerator is 2 times the square root of 29. So you can see it's pretty easy to go ahead and simplify this. And now if I could have simplified 2 over 29, I would have done that. In this case, you can't do that. They don't have common factors. So this is the final result. Now let's take a look at another scenario. Suppose I have 2 over the square root of 2. In this case, you can approach this the same way. Multiply by square root of 2 over the square root of 2, and I get 2 square roots of 2 over 2, and of course the 2's cancel, and I get the square root of 2. But there's another way to think about this. Suppose I start again with 2 over the square root of 2, and I think of the 2 in the numerator as being the square root of 2 times the square root of 2. Then I can just cancel one of the square roots of 2, and I'm left with the square root of 2. So either way, I get square root of 2. Just that this way is a little bit quicker, and it tends to come up quite a bit. You'll see that quite a lot in this class. So especially when you're dealing with a multiple of a 45-degree or pi over 4 angle, you'll see that kind of relationship quite a lot. So that's how you work with radicals.